Let's learn about the proxy pattern. The proxy pattern is once more amongst those design patterns which have become such an integral way in which we work that we don't think of it separately as a design pattern. So, what is a proxy? A proxy is a stand in or an agent or an interface for some real code which is running elsewhere. What do I mean by the code is running elsewhere? It's possible that there's a separate system running on another machine, and the interface to that system is used by you in your code running on another machine. So the proxy is that interface which you use to integrate with the real subject, which is the system running on the remote machine, which does the actual processing. Now, there is no limitation on what that system is for which you have a proxy. It could be a file on disk, and maybe the proxy holds different views of that file. It could be like some servers which run a whole bunch of APIs. Anything can be the real subject. What you deal with is the proxy. The prototypical example of the proxy method is something known as remote method invocation. It's a very fancy term for basically calling an API which lives on a different machine. So basically asking to process stuff on a different machine and invoking that code from yours is called remote method invocation. Now, RMI was a way in Java to make method calls to code that resided on a different machine. This was a big deal back in the 90s. Now, when we program, we assume that the server and the client will live on different machines. We assume that processing will be split across multiple machines. But when RMI came in, it was pretty revolutionary. I say was a way in Java because RMI has now been superseded by much more sophisticated way of doing things. For example, REST APIs. That's a way of invoking code on a different machine. RMI was an important step in the evolution of distributed computing. If you think about distributed computing with code running on different machines which can call each other, RMI was an important step towards that objective. And RMI was built squarely atop the proxy pattern. Now, what happened when you made an RMI call? On your local machine, you'd get something that's called a proxy object. This proxy object would serve as a stand-in for the actual object that resided on a different computer. It would have all the interface characteristics of the real objects, but when you made method calls on it, it would actually marshal its arguments, send it over the wire to the remote machine, get the processing done, and get the result. You on the local machine always dealt with the proxy. The underlying principle of the proxy pattern is that one object, that is the proxy, controls access to another. What does this mean? This means that anytime you want to access the real subject, which perhaps is on a different computer or could be on the same, you have to go through the proxy. The proxy gates access to the real subject. The controlling object is called the proxy, or the other term for it is the surrogate. It's a stand-in for the real object. It also controls access to it. Now, in remote method invocation, a proxy is also needed for another reason. A proxy is needed to abstract the programmer from the nitty-gritty of dealing with an object on another machine. So there's this whole bunch of object marshalling, connecting over the network to a remote computer. All of these are taken care of by the proxy. So when you run code on your local machine, you don't worry about these details. You simply use the proxy object like it was the original one. A proxy, as used in the case of remote method invocation, has a special name. It is called a remote proxy. Alright, let's see how these proxy interactions work. So we have two computers, one which we'll represent on the left and the other on the right. On the left, we have the client. That is the one which makes the call to an object or to an API or to some processing on the other computer that you see on the right. That is the server. Let's see how control flows. We have the client code running on the client machine and the server code running on the server machine. These have to interact. We have the RMI proxy object, which is what the client code uses. The RMI proxy object sits on top of the RMI runtime, which takes care of a whole bunch of things, connecting over the network, object marshalling while passing input parameters to the server and receiving results from the server. So the RMI runtime exists on both the client and the server. And on the server, you have a skeleton object which is sent to the server code. Control flows both the ways. Proxies don't just act as an interface or deal with the nitty-gritty of network connections. They can also do other useful things. For example, if a call through a proxy is expensive, the results of these method calls can be cached. For example, if the proxy is for a command object, it could maintain a cache where the key of that cache is the set of parameters from each call to the command. So you pass in a set of parameters to the command and the command runs. So we use the set of input parameters as the key, and the value that you store is the result of the command. So the next time we see the same set of input parameters, you just fetch the result from cache. Now this particular technique seems very clever, but it's actually really common, and it has its own name. It's called memoization. Memoization can lead to huge performance improvements, especially for computationally intensive tasks or those tasks which require a lot of input-output operations. If you can do without real-time data, you should cache it. And the proxy is a good place for caching these. So, here are a few examples of the proxy pattern. Hopefully, that got your head wrapped around how exactly it can help us.